Hello and welcome to graphing quadratics in factored forms. This is our third form. Remember, we had standard form, we had vertex form, and now we have factored form. So in this video, we are going to be looking at this problem. And basically what factored form tells us is, remember, if when we did zero product property, we learned that if I set this equal to 0, that's the same as finding the x-intercepts, because the x-intercepts are where y equals 0. So that's on the x-axis is where y equals 0. So I'm setting this equal to 0, and that gives me the x-intercepts. So this equals 0, and then I can just divide both sides by 3/8, which will get rid of it on this side. And on this side, 0 divided by anything is just 0. So essentially, I can ignore the number in front for this part. So I have, and I can split it up into x minus 1 equals 0 and x minus 9 equals 0. Remember, that was the zero product property. We said we could do that. So x minus 1 equals 0 and x minus 9 equals 0. And then I can just solve for x. So I didn't actually need the parentheses. We can add 1 to both sides. We get x equals 1. We can add 9 to both sides. We get x equals 9. So these are our two x-intercepts. So the graph is going to cross the x-axis here at 9 and at 1. That's what we just found out from factored form. So the graph is going to cross the x-axis at 9 and 1. And I know, because I know that parabolas are symmetric, I know that the vertex is going to be halfway in between these two. So to get the x value of the vertex, I can take the average of my two x-intercepts. So what we were finding here was x-intercepts, and what we're finding here is the vertex. It's the next thing we're finding. Okay, so the x value of the vertex is the average of my two x-intercepts. So that is 1 plus 9 divided by 2. That's the average of my two x-intercepts. Which is 10 over 2, which is 5. So my x value of my vertex is going to be 5. Let's find the y value. So the y value is going to, I'm just going to plug 5 into my original equation. 5 minus 1, 5 minus 9. So 3/8, 5 minus 1 is 4. 5 minus 9 is negative 4. And I'm going to write over here because I'm running out of room. So 3/8. 4 times negative 4 is negative 16. And then I can cancel the 8 with the 16, and that becomes a 2, right? 16 divided by 8 is 2. 2 times 3, negative 6. So we have that negative here. Or you could just put this in a calculator if you're not sure on the mental math. But so negative 6 is the y coordinate of my vertex. So my vertex is 5, negative 6. So I'm going to plot that. So I'm going to go to 5, and I'm going to go down to negative 6. And that's my vertex. I could get some in-between points. So if I want to be thorough, I could get, say, 3. Could plug in 3. So if I plug 3 in for, what am I doing? If I plug in 3 for x, I get plugging in 3. Get 3 minus 1 3 minus 9, which 3 minus 1 is 2. 3 minus 9 is negative 6. So we have 2 times 6 is negative 12. Negative 12 times 3 is, hold on, it's negative 36 divided by 8 is negative 4.5. So this is going to be negative 4.5. So our point here is 3 comma negative 4.5, because that's what we plugged in to x was 3. So 3 and negative 4.5 would be right here. So basically we're just finding this point so that we can just have a thorough curve. It's good to have, like I said earlier, it's good to have 2 points on either side of the vertex so that we can really see what our shape is going to be when we're doing this by hand. I could have picked 2, I could have picked 4. I decided to pick 3 because it's in the middle between 1 and 5. 3 is 2 away from 5. So if I go 2 away from 5 to 7, that would also be at negative 4.5, because again, this is symmetrical. If that doesn't make sense to you, just go ahead and actually plug in the numbers and that will be fine. All right, so my vertex is, oh no, my points are moving. Don't do that. Move this to the 9. The vertex was supposed to be at 5, negative 6. Sorry, all my points moved. Except for these two, they're still there. All right, so the vertex is at 5, negative 6. We have zeros at 9 and 1. And then these points that we found. Good. All right. So hopefully all of that makes sense. So let's look. So in this question, they're not adding anything. So we're still going to set this equal to 0. I accidentally paused it. We're still going to set this equal to 0. But we're going to, so when we split it up into our equations, we're going to have x minus 2 equals 0, and we're going to have x equals 0, because this doesn't have anything else with it. So it's just x equals 0. So we don't even have to solve this. This just is x equals 0. We know that. So again, these are the x-intercepts we're finding when we set it equal to 0. We're going to add 2. So we get x equals 2. So our two intercepts are going to be at x equals 0 and x equals 2. And then the vertex is going to be halfway in between at x equals 1. So the official way to find that would be to take the average of 2 and 0. So 2 plus 0 divided by 2, which is 2 divided by 2, which is 1. So the vertex is, the x-coordinate of the vertex is at 1, and then the y-coordinate, we have to plug 1 into the original equation. So we get negative 6, 1 minus 2 times 1. So we have negative 6, 1 minus 2 is negative 1. So we have two negatives. So 6 times 1 times 1 is just 6. Negative times a negative is a positive, so this is going to be positive 6. So the vertex is at 1, 6. That's going to be our vertex. Now notice that this is negative, so this parabola is going to be facing down. 1, 6, we're right here. So if I start putting things where they're actually going to go, my My vertex is going to be here at 1, 6. And I'm going to have an intercept, an x-intercept here at 2, and the other x-intercept is at 0. So if I'm doing this by hand, I might want to find another point, but the truth is, if I do, it's going to go off the graph. So what I would probably do is I would go ahead and plug in 3 to my equation and see that the answer that I get is not going to be on my graph. So I would not end up graphing that. So just to demonstrate, if I plug in 3, I get -6, 3 minus 2 times 3. So that's -6. 3 minus 2 is 1 times 3. So that's -18, which does not fit on my graph. So I don't have to plot that. But the general rule was to have 2 on each side. So we want to check, but in this case, only 3 fit, and that's fine. That can sometimes happen. So that is how you graph that. Yeah, and then this would be the same type of deal. All right, hopefully that helps, and I will see you in the next video.